Let's further talk about the current. We know that current has two factors. One is the direction of the current. Second is the value, the quantity of the current. So with these two factors specified, the true picture of the current has been defined. We do not know the true direction of the current flowing into this branch to that branch. We just don't know. So what do we do before we analyzing the circuit? We assume the direction of the current first. In this case here, I assume that the direction of the current is from A to B. Okay, and after all calculation from other circuits connected from A to B, and I found that, okay, the quantity of the current is 5A. That's fine. Okay, talking about the same circuits, I can define the direction of the current in any direction because I do not know the true directions, right? Okay, so in this case, I define the direction of the current from B to A. So this direction here. I'm going to use different color here. So from this direction here now. And now using this, analyzing the circuit, you do the same thing. And I found that the current is minus 5A. Both notations here, this and this, are both correct. They are equivalent. Either one, A or B, gave the whole picture of the current here. One of the common questions I normally receive is that, oh, okay, which direction I'm going to assign? If I assign the direction from B to A, it's not correct. And let me answer that any direction you assume for the current directions is correct. Any direction you can assume, but you need to specify correctly the quantity. The quantity. Once the quantity has been defined with the two parameters together, we have the whole picture of the current. So just by saying, okay, I'm not allowed to define the current directions from here, from B to A, that's not correct. So I can define any directions, but you need to define the quantity, and the quantity has plus sign or minus sign. Next, let's talk about the concept of DC and AC. DC is a direct current. The current does not change with time. The other one is AC, alternating current, which means that the current is changing with time. They can change it in different style, triangular, rectangular, or sinusoidal wave, things like that. Let's use an example to talk about the current. We want to emphasize again, current has two factors. One is the direction, the other one is a value. With that being said, current is actually a vector. When we calculate the current, we need to consider both factors. One is their directions, and second, their values. Okay, so in this case here, what is the resultant current flowing from point B to point A here? We know that there is a current flow into this direction to the left, that's 3A, and then from this direction here to the right is 5A. We know that current vector, so there's this direction, that direction. When we operating on vectors, we prefer that the vectors are in the same direction. So we change this, we change direction of this vector. Okay, if I change direction here, so 5A is equivalent to minus 5A if the direction of current is changed to the opposite direction. Now these two vectors are in the same direction. I can add the values mathematically. So 3 minus 5, that's minus 2. That's the current, that's the resultant current from point B to point A. Physically, this scenario, I mean, this scenario here, we can think about that when we walk here using 3 meter per second, but there is a headwind. There is a headwind 5 meter per second in this direction. So what's the result? We actually walk backward 2 meters per second. This is exactly what happens here.